we're going to start with something a little bit more complicated, what we did last on Monday. So, but it's gonna be a detail like a roof with thermal insulation and rafters. So let's do that. We're going to draw a 6-inch thermal insulation, and then we have an internal finish of 1/2-inch plywood, and there will be a 1/2-inch plywood above. Okay, something very simple, but let's create a rectangle first. That rectangle, it's horizontal, so we're working on a roof, so it's something horizontal. It has to be 6 inches. So this dimension here, dy, has to be -6, and this can be let's make it doesn't matter, it can be 9 or 10, a rectangle like this. This rectangle, we have to change the material, and we need any insulation. Let's select insulation fiberboard. Okay, now that's the thermal insulation. What we need now is a rafter. So we need another rectangle, and the rafter, it's 2 by 6 inches. So the width is 2 inches and the height is 6. Okay, so this rectangle has to be 2 by 6. And if we select this material, this has to be wood. Wood, when we're talking about the structural wood, it's pine. Okay, so here you have pine, or at least I have pine. So let's select this material. And now at this side, we need the same rectangle with the thermal insulation. So if that was, I think it was 6 by 9, I'm going to create another one, 6 by 9. And now I click here, and it's insulation fiberboard. Okay, so that's a roof, thermal insulation, and a rafter in the middle. Now we need the internal finish. So I'm going to create another rectangle here. We can say 1/2 inch. And then I click here. And this is particle board plywood. We have high density, low density, medium density. There's, okay, so let's select the high density. It matters, but so far, let's select high density. And now we create another rectangle here. And we have 1/2 inch particle board, high density too. Okay. So it's a simple detail, but now it's interesting because we can do this with the Excel file. We can analyze a detail that has 2 different materials. We can, but we have to create 2 different tables. So now we need to work with the boundary conditions. So select BC, click here, BC, draw boundary conditions. And now we have to pick the internal one, this one. And if everything works, the boundary condition that we have here, yep, I created this internal 71.6. Remember that we did this one. Okay, so that means that the indoor temperature is 70, and this filtering coefficient is 1.6. So that would be the internal condition. And then if I click boundary condition again and click here, I have to select the external. It's 20, 2.9. 20, it means that we have 20 Fahrenheit outside. 2.9 is the same coefficient, is the film coefficient. If we are in a different place, if the temperature outdoors is 0 Fahrenheit, we have to create a new boundary condition, a new external boundary condition, and the name would be 0 and 2.9. 2.9, it's fixed. Okay. So if we do this, now we have the internal boundary condition, the external boundary condition. And we are not done yet. We have to go to libraries, and then we have to, well, we have to select one of the boundary conditions, library, and then we have set boundary condition. And by default, this is the external, but the U factor surface is none. Okay, we have to select X because we created this one. And then check, we have external, it is X, the temperature is 20, the film is 2.9. Okay, so it's what we want. So we click OK. And now we have to select the internal one, library, set boundary condition. We have the internal, but the U factor surface has to be int. Okay, so it's internal, int, the temperature is 70, the film coefficient is 1.6. Okay. So there are a lot of things. We have to we have to draw the rectangle, we have to select the material, then we have to select the boundary conditions, internal 70, external 20, and then we have to assign the U factor surface. Okay, so it's always the same, but if we miss one step, we're lost. Okay, so now if everything goes well and we calculate this, we will have the isotherm lines. But what is interesting here, if we go to calculation, display options, and I show flux vectors. Okay, so now something happens here. It's what I was expecting. The arrows through the thermal insulation are very small. The arrows through the rafter, they are bigger or longer at least. Okay, so that means that there is a thermal bridge here. Okay, if we go to calculation, display options, and we show the color flux magnitude, if we show the color flux magnitude, I think by default this show legend, it's activated. We can show polygon outlines because it will help understand what happens here. Okay, so select color flux magnitude, show color legend, and show polygon outlines. Click OK. And now we have this. Okay, so that is something interesting because now we have a color code and we have the legend. Because without the legend, we can understand what happens here. So something is happening in this where the rafter is. And what happens? Look at this color. So the heat flux here is 2.5, very low, but the heat flux here is 6.9. So that means that we are losing heat through the rafter. Well, we are losing, yeah. So we are assuming that we have this, we have to understand what we see here. So that's why the legend and the drawing, we need both things. Okay, so the heat flux here is 2.5 and here is almost 7. The heat flux is the rate at which we lose heat. Okay, so we're losing 3 times as much heat through the rafter than through the thermal insulation. That makes sense. Okay, but now we have a number. So if we fix this if we fix this detail, what's the improvement? So that's why we need to compare. So I'm going to take a screenshot of this detail. Okay, I open my PowerPoint. And that will be option 1. And now I had to compare option 2. But now I know that option 2 is going to be better, but how much better? So we have to look at those numbers. So that's why we need the colors and we need the scale. The colors are not enough. So let me try. It won't work. Would you like to stop what I'm doing? Yes. Okay, so yeah, so it's hand in the neck, and this color legend is still there. Boundary condition, okay. Okay, so I'm going to try something. I don't know if it's going to work. Imagine that this is a real world. I have this roof and I have to refurbish the house and I have to let my client know the savings in energy. Okay, I'm going to create another rectangle here. Let's say 3 inches. Okay, when we do that, this boundary condition, it's not a boundary condition anymore because we have another material there. So I have to select this and I'm going to select the thermal insulation fiberboard. Okay. And now I'm going to create another layer here. And let's do this a particle board. I don't know if it's going to work. Okay, so THERM is very sensitive. And I don't know if here we will have some issues. Let's see. But this is what I do to fix the thermal bridge. What I do is to increase the thermal insulation and to prevent that this structure is exposed to the outdoor air. So either indoors or outdoors. In this case, it's outdoors because that's the internal boundary condition. So I placed 3 more inches of thermal insulation above the rafter. And now I have to select this thermal insulation again, this boundary condition again. It has to be external. And in library, set boundary condition, and I have to click X. Will it work? I don't know. Let's see. Calculation. Well, it works. So now if I go to display options and go to flux vectors, okay, you see the heat is inside and it tries to get out. Okay, so here we have this, it doesn't get out or it gets out at a lower rate through the thermal insulation. It tries to get out through the rafter, but it finds another thermal insulation there, so the arrows are smaller. Okay, so that's what happens if I go to display options and show the color flux magnitude, and I click OK. Okay, so what is the result? Take a screenshot here. Okay, the colors are the same. Okay, so the colors are not enough to understand what's going, but the scale is different. The lowest number here was 2.5. Now the lowest number is 1.6. And the highest equals almost 7, and this is 4.3. Okay, so I have reduced a lot the heat flow. How much? From, well, the maximum heat flow from 7 to 4.3. So I have reduced 30–40% the heat flow. That means that I have reduced 40% of the energy that this roof is losing. Okay, so I know that, yeah, placing thermal insulation, it's going to improve the detail, it's going to reduce the heat loss, but how much? Because, okay, look, yeah, but how much does it cost me to put this thermal insulation, this extra thermal insulation on the roof, and how much energy I'm going to save? This is what we have to find out. It's not just a question, place 2 inches of thermal insulation. Why? Because everybody does it. And replace double glazing for and just use triple glazing. Why? Well, now, yeah, we know what we have to do, but the challenge is to understand how much energy we save and how much money we have to spend upfront. Okay, so that's this is what the client is expecting from us. So with this, I have a simulation and I can tell my client, okay, if you do this, you will save 30%, 40% of the energy that you're losing through the roof. Is it worth it? Okay, how much does it cost? How much does it save on the first year, in 10 years, in 20 years? So this is the kind of analysis that we have to do. Okay. Any issues? Do you all have something like that working? Yeah. Yes or no? No. Okay. Um, if it's this, let's let yeah, you have issues with the problem. You have the volume here for yeah, if the half inch is too small, try 1 inch. It doesn't affect that. Okay, anyway, I'm becoming an expert on THERM, and usually when I do something on the screen, it works. But it happens to me after 5 or 6 years using THERM. Okay, at the beginning I had a lot of issues. So you are having issues? Yes. This is the first time for you using this kind of thing. But you have to practice, and eventually it will work. Yes. Right. You have overlapping. Okay, let me finish this and then I'll try to fix that. There are a lot of things that can go wrong. We can have overlapping polygons. If we have overlapping polygons, we have to select the rectangle or whatever we have done, delete it, and do it again. There is no way. And sometimes it won't work, and sometimes you have to close the file and do it again. So yeah, it takes time. When I do it, it works because I have practice, not because I'm smarter than you or well, I'm older and I have practice. That's the only thing. Anyway, what I want to show is what we can do with calculation, display options, and I'm going to show the flux vectors. It's interesting because I can understand that most of the heat, as I was predicting, most of the heat is going that way. There's no heat going down because we have that means that we have a lot of soil, so the heat doesn't go out that way. The easiest way for the heat to get out of the building is through the slab and the footing. Okay, so this is what I was expecting. And so I can take a screenshot of this one. And yeah, so let's start preparing another report on THERM. I'm gonna make it smaller. Okay, so that will be the first option. Here again, this is the first option. But now I want to see the arrows, I want to see the vectors, and I want to see the colors. So I go to calculation, display, color flux magnitude, and show polygon. And let's do this. And let's see what happens. Yeah, so that's very usual. It seems that it has crashed, but it hasn't. Okay. So every time it does this, it will create 1 pixel more of simulation. Oh. Okay. Good. And we have a legend. Okay, so the legend here, it's 0. So it means that here we don't lose in heat. Okay, so here we're not losing heat, all the heat. We are losing here at 22, because we don't have any thermal insulation. When we only have concrete, we have a lot of heat losses. Okay, so that would be the outcome of the analysis. Control V. And yeah, if they are at the same scale, kind of, that will look nice. Okay. I expected that, of course. I don't have thermal insulation, I have a thermal bridge, most of the heat will be here, but now I can quantify how much heat goes out of this element. So there's a third thing that we can do. And the third thing is, in calculation, show U factors. Okay, so show U factors. And okay, so what do we have here? We have the U value, we have the R value, and this here we have U, delta T, length inches. This is exterior, this is interior, and this is projected Y, projected Y. We have to select here a total length for both. Okay, so what does it mean? Let's go to the R value because I think it will be easier to understand. So the R value that we have in this detail is 8 or 9. What does it mean? The exterior and the interior. Well, it depends on the surface. But anyway, if it's between 8 and 9, we are far from the goal of 50, because if we have a floor to wall transition, this U factor, or this R value, should be something between 30 and something between 30 and 50. And now it's 8. Okay, so what will be our goal? The goal would be, if we are refurbishing this house, so the goal is to make this very close to something between 30 and 50, because we are between the roof, the floor should be 30, the roof should be 50. Okay, so this transition should be something between 30 and 50. So that's the goal. Now we are in 8, 9. We are far from the goal. So when